Good day students, today we will discuss Unit 3 in Computer Organization and Architecture. So what you will get as an output of this unit, that is after studying this unit you will understand pipelining concepts and basic processing units of computer architecture, and then how you can perform the operations. Okay, what are the processing units are there and how you can perform the operations. So that is the basic flow of unit 3. So next you will teach fundamentals. Okay, so what we will cover in this unit 3 is fundamentals of basic processing units, ALU operations, execution of complete instruction, multiple bus organization, hardwired control, generation of control signals. So we will see each and everything more in detail. Just I am reading the topics. Okay, so micro program control, micro instructions, micro program sequencing, micro programmed instructions with the next address field, and after this we are having the concepts of pipeline complete and hazards in the pipe. So first half is completely this first half is completely gives you an idea about basic processing units and how the programming is carried out in this. So next half is completely on pipelining. Okay, so we will see everything in more detailed, right? So first we will see basic processing unit. This processing unit, as you know, so what are the functional components of CPU? So you know from your unit 1. So I have an input. So input devices are there, and we are having a CPU. So the CPU, what is CPU having? CPU having a control unit, arithmetic logic unit, and memory unit, right? And then we are having a output unit, and this memory unit deals with the various types of storages like RAM, ROM, like that. So this is basic processing unit and functions of processing unit. CPU will be having, so CPU will be having all the datas, and registers, control unit, arithmetic logic unit for doing basic operations. Okay, so next we will see. So what is what is the things, what are the fundamentals for an instruction to execute. See, for example, you are giving an instruction, add 4 comma 5, add r1 comma r2 in two registers. Okay, the let me change. So you are giving an so you are giving an instruction, add r1 comma r2. Okay, so what this instruction, initially what you need to do, so you need to fetch this instruction. Okay, you need to fetch the instruction, and you need to, where you will be fetching the instruction, the instructions will be fetched in memory locations. So whatever the instruction, so for example, jump not equal to 0 means this jump instruction will be fetched in particular place. Oh, after that, so what your program counter will do, everyone will know program counter, PC we will say. My instruction register IR is nothing but the instruction register, so that will be pointed to program counter. So this IR will be having the values of program counter, means this register value. So IR contains the currently executing which instruction I need to execute, that will be having this IR. So instruction execution, how it happens? First I need to fetch this instruction in the memory location. I need to perform the operation. So addition operation, decode is nothing but determine the opcode and operand. So here we are having this addition operation. This operation need to be performed, and finally this instruction need to get executed. Am I correct? So these are this fetch, decode and execute. So this is the basics of your fundamental processing unit, how your programming works, right? Everyone knows this. Now if you see a little more example, what happens when you are doing fetching with program counter, right? We will see this within single bus organization. In unit 1 we already studied single bus to multi bus like that. So with an example we will see what is happening in the single bus architecture. If you see the single bus architecture, as we said, the memory instructions, my instruction is getting fetched in this instruction register, that is with the help and the IR, that is instruction register will fetch the current value in program counter. So now it is getting incremented with the value of 4. Now the question, why it is 4? See, that is nothing but since it is designed for 32-bit, it is given as 4. If it is for 64-bit, then the program counter will be incremented PC plus 8. Okay, so since it is an 32-bit registers, so it is given as 4 5. After that, what we need to do, see, we have done now two things. One is instruction fetching, and we have done some means we have incremented the program counter accordingly. Now what we need to do, we need to do an execution phase. Now this execution phase is having many things, so this is somewhat important to note down. Okay, so what important means, I'll tell you. So in instruction execution, we are having registers, that is MDR, memory data register. In memory data register, it is a two input, it consists of two input and two output. Okay, that is the data are being loaded from memory or processor bus. See here, either from here to here or from here to here. Similarly, see, it is a bidirectional, both the sides we can send and receive data, that is from bus to memory or from memory to bus, like that. So the similarly for MER also, A stands for address. Okay, MER, memory address register, MDR is memory data registers. Okay, so it is connected. And then the control lines. So control lines, obviously you know, the control lines are why it is connected to give signals. Some signals you do, you perform this operation, do addition or stop this instruction, like this. For doing signals, these control signals are there, and we are having registers. Obviously with the help of general purpose registers we can do our operation, and we are also given temporary operations in single bus organization. So temporary registers are used to store the values temporarily. So finally we are having everything will be in the data path with which interconnects all your architecture. So this is the execution happens in a single bus organization unit. I hope it is clear for you. And next, if you see, so same thing what we discussed here. So step by step it is given. So whenever I am transferring, okay, whenever I am having some exceptions, and that exceptions need to be executed. So what happens initially, the given word, okay, given word, the register the datas are given from one processor to another register or another processor, or in the form of any addition or multiplication, it is given to arithmetic logic unit, and you perform. Okay, you perform that. Say, just take the same example, addition of two register values, add R1 comma R2. So we need to perform addition, right? So that arithmetic operation will be done, and it will be stored in the processor register. So processor register stores the value, that is add R1 comma R2. R1 stores the values, that is R register. So R1 stores my value. So for the instruction add R1 comma R2, okay, I am just explaining this. So R1 stores all my values. After that, fetch the contents to the given memory location and load them into processor memory. After performing the operation, it will fetch into corresponding memory location where it wants. Okay, finally it will be stored. The word will be stored in the given memory location. So this is very basic understanding, that is instruction fetch, process, okay, that is execute, and then finally you can store the values. So this is the basic understanding of how it is working. Now you can see this with an example. I'll stop this, I'll continue next week.